This is a continuation of our second set of practices. In the previous class, Anna had elicited students' ideas about how soda pop could be distilled into a clear liquid. She heard a wide range of ideas. She decided to adapt her instruction for the following day by showing students 4 hypotheses that they had generated the day before. In this way, she again makes public and visible their thinking, and now asks her students to take a stand on one of these hypotheses.
So right now I should see everybody reading the directions. You're only copying A, B, C, or D. You're choosing one of these sentences and copying it based on how much it makes sense to you for explaining what happened yesterday.
If we read these hypotheses carefully, we see that they are not written like a multiple choice question where one is correct and the other is incorrect. Rather, because these came from students themselves, they reflect the way the students are currently thinking. All the hypotheses have some truth value. All of them try to mix observational language with science ideas to explain what happened, but none of them provide a clear explanation of what's happening at the unobservable level of distillation. Anna will press them now to select one and defend it, but also to evaluate the others as possible alternatives. This is what we refer to as opportunities to reason, which in turn support learning.
Okay, so yesterday we saw all the way to the end. This is what ended up being left over from the Coke flask. This is the original flask. This is what was in the other one, okay? So take a look right now. This is your opportunity. Okay? So why didn't this boil away? Why is this clear when this started out as Coke?
Anna focuses her students on what's left in the flask after the distillation. She hopes that this will influence their thinking about which hypothesis they intend to support. She moves from table to table now, pressing their thinking.
I thought, it says, what do you think left behind? I just put the steam and the sugar. When it boils, the steam just stays there, and the sugar from the Coke, just takes out the sugar and you can't drink it anymore. The steam, when it comes up, it's just not water, it's just hot steam. I think that the Coke has too much sugar and takes all the water and left it here and leave all the sugar. That's why it looks like soya sauce. It's like sour. No, how is it? Syrup.
Okay, on the screen is a zoomed in leftover of the Coke. So this is, we started with 75 milliliters of Coke in here. This is all that is left, and I showed it to you. It's not like, see how syrupy that is? How it's kind of sticking everywhere? Yeah. Okay. So if I take this here and I add it to this flask, how much do you think we're going to have? 80. So some people are saying we'll have the same amount we started with. Some people are saying we're going to have more than we started with. So I want to hear from the people that said we'd have the same amount first. Why do you think we'd have the same amount? I want to see hands. Why would we have the same amount that we started with? Okay, Curtis, you're going to just threw it out there? Okay, cool. Do you have any reasons for making that guess instead of a different one?
I say no.
Okay.
We're gonna have.
Anybody have a reason that didn't just throw out a guess? Alicia?
We got 75. It evaporated or like went into the tube to that house, and if you add it, it'll be the same amount.
So you're saying that the connection between the two flasks meant that nothing could ever get out? You said it's going to be the same amount. It's just going from one to the other. Okay. Anybody want to argue for the more? Why we would have more than we started with? Okay, and Delbert, are you willing to tell everyone why you just told me that there would actually be less? No? Do you have a reason? Just guessing? Okay, Alana?
I say that there's less because not all of the coke is gone from the bottle that was put out with.
So explain your thinking about that a little bit more. So you said there's some left in here?
Yeah. Since some of that thing that were transferred to a separate one, second bottle, didn't all get there because there's some left in the first one.
So if I recombine it, shouldn't it be the same amount? Or not? Well, what do you think? Why wouldn't it be the same amount? Where would it have gone?
Because some of it was there.
How did it get to the air? We had it all closed up. Oh, it popped off. Okay, guys, you want to add something?
It's gonna be less.
Maybe less? Same reasons as Alana or different? Alright, let's see what happens. So where's 75 on there? This is 75. So we have just over 50 milliliters. So we have less. Okay? So now we know what the answer is. We have less. So why do we have less? I've heard from people that it should be the same because all that happened was something moved from one flask to the other one. But then Alana said, well, that's not what happened because I saw it pop off and it went into the air. How did it go into the air?
You know, how if the soda was
Hey guys, we're period. Let me just give you a reminder. When one of your classmates is speaking, especially when they're sharing their ideas, we listen. So let's go over what that means. You should be at a voice level 0 right now. You should be turning yourself towards Raul so you can hear his idea. And you're listening in a way that will allow you to repeat his idea.
you know how the soda was evaporating and it was going to the other one. So when it popped up, it threw away most of the evaporated gas that it was going through the tube, and that made it like become this.
Okay, this is the second time, Raul, that I've heard you use the word throw.
What?
Use the word throw to describe how the steam is moving or how the gas is moving. You said it got thrown away.
It like shot away the gas.
So you're talking about the suddenness of it? The
Yeah,
speed?
you know how the tube it popped up, then the steam just shot away, and that made it, you don't have gas.
Okay, so there's something going on with the speed of everything that's happening here. All right. So I want you to look up at our learning target. I will be able to record and share my ideas. Right now, if you look at your paper, you should be able to say, yep, I have recorded my ideas because all those spaces should be filled. You should have zoom-ins and drawings. Your ideas should be recorded. So our next step is to share them. Number 1 is 0 minutes when the Coke is frozen. Number 2, after 10 minutes the Coke is melting. So if you could see past the Post-its, you would see there's a chunk of frozen Coke and some liquid Coke in that flask on the left. Number 3, after about 20 minutes, now the Coke is boiling. Okay, so I drew some bubbles in there. The lines are really wild because you saw how much that water or that Coke was moving around a lot. If you look to the right flask, you can see there's a little bit of clear liquid in the bottom of it now.
Ice water.
Number 4, after 30 minutes, the Coke is totally boiled away. So now there's just this nasty syrupy set at the bottom of the flask, but there's a ton of clear liquid in the flask on the right. We are going to use those ideas you had at the beginning of class to try to explain different parts of what happened yesterday. All the Post-its you see up here are from first and second period. So this isn't just your class. We're actually sharing our ideas across classes. So we're going to try and come up with a bunch of different reasons why this stuff is happening. We're going to post it in the room, and as we learn more about what's going on, we might say, oh, that wasn't true, we're going to take that Post-it off. Or we might put a big star on Post-its that have ideas on them that we've verified with labs and readings and stuff. Or we might add more information or add post-its even. Okay? So this is going to be something that's up in our class this entire unit. I'm going to have you arrange yourselves into groups based on the hypotheses that you chose at the beginning of class. So the one that you wrote for your entry task, you're going to be in a group of people that are thinking the same way that you do. That's my goal. That's what the colors of the post-its mean. So the purple post-its are for people who chose hypothesis A. So we're trying to see if those ideas can help us explain a lot of our big model here, or if they can only help us explain a little bit. Okay? You will get one of these with your group. At the top it has your hypothesis on it. So everybody should look at the paper that I'm holding. This is for people who chose A. It says the pressure from the heated air made the liquid move into the other flask. Okay? There's some highlighted words on here. Those highlighted words are important because I have chosen them as parts of your hypothesis that sort of capture the biggest ideas. All four of these ideas are ones that I heard yesterday, so this is coming from you, but I've just kind of highlighted some of the key words. Attached to this paper are 6 post-its. Okay? Each one of these post-its you will use with your group to answer a question. On the white paper that you first get, there's 2 questions. Those are for the first 2 post-its. You will get the second set of questions and the third set of questions when you finish these 2. So we're just working one step at a time. These 2 questions are about the frozen Coke. But remember, the key here is to use these highlighted words on your post-its. So I want you to take up the perspective. Remember that whole listening thing? Practice it. I want you to take up the perspective of this hypothesis. So use these words on your post-it. Every post-it your group writes, if you're A, should have the word pressure and heated air on it. Okay, I'm really trying to get you to think hard about the ideas you've suggested and what they mean about all parts of the model. So the post-its, once you're done with them, you're going to stick them onto the posters to show what part of the model they're explaining. So Alano, if we have a ton of post-its on the frozen Coke flask but none on that empty flask, that means that we have had a lot of people explaining what's going on here, but nobody has even taken a whack at explaining this. So the parts that have the post-its on them are the parts that people have been trying to explain.
Put that away. Use this video to write and answer questions. Come on.
Right now, you're filling out as a group of 3 2 post-its, 1 for each question. Okay, so you gotta listen to these directions. So your hypothesis is that the soda gets pushed into steam. So I want you to use the words pushed into and steam to talk about what is happening to the molecules of frozen as it melts into a liquid. So what does steam have to do with melting?
The other flask, when it hit the bottom, it turned into this little liquid.
So you just told me a big long string of what you saw, right? So now I want you to push yourself a little bit further, and I want you to tell me about why you saw one of those things. So this is asking you to focus on frozen to liquid, so melting. So can you tell me why you saw that and what it has to do with steam? Can you tell me something about the molecules of the frozen Coke? And maybe one of your group members can help you out since you've been carrying it for a while. What do we know about the molecules of the frozen Coke, gentlemen?
Oh my God! That's right there, right? Why are we whispering?
vibrate, and like when it was frozen, when the cork was frozen, there was like the molecules were like in together, and they were just like vibrating. They weren't like moving or they were like shaking.
And when it got hotter, they started to separate from each other and having less excitement.
What do you think about that? Is it genius? Why? So try to explain to me why Fuchsia makes sense.
Here, students have used their initial hypotheses to try to explain what happened at different stages of the distillation. Anna wants them to understand that a good explanation accounts for multiple parts of a phenomena. She also wants them to experience some initial dissatisfaction with these mini theories. We can see, too, that from the colors of the post-its at this point, it tells us that the students favor each of the 4 hypotheses nearly equally. In upcoming classes, Anna will provide investigative experiences that target each aspect of the scientific explanation as she helps students revise and refine their ideas.